Now we're going to learn how to take the derivative of natural log of x. So if you stick this into the difference quotient, back over, limit as h goes to 0 of f of x plus h minus f of x over h, it's messy. It's not nice. But it's much easier to do this with implicit differentiation, which we just learned. So we're going to do it that way. So by definition, remember that the logarithm is defined as the inverse of the exponential. So if I have this means e to the y equals x, right? And I'm going to differentiate this. And then I'm going to solve for dy dx. Okay? So this is easy enough to differentiate, right? So I end up with e to the y dy dx equals 1. Right? So that tells me that dy dx equals 1 over e to the y. Well, that's great, but I don't really want an answer in terms of y. I want an answer in terms of x, because I want to just be able to take the derivative here. But look, I can substitute back in. Either way, I can substitute this, or I can substitute y equals natural log of x. In any case, that bottom is just x. So I have the derivative, dy dx is 1 over x. Okay? And that's just what it is. So the derivative, all right, then okay? Now, just as an FYI, if you remember, I don't know how, we didn't go over this very much. If you remember though, if it's not e, right? If I've got y equals b to the x, then the derivative of that turns out to be b to the x natural log of b. We did talk about this, right? We did a thing. Okay? So what it turns out, if you do the same thing, right? Here, if I have y equals log base b of x, I just do the same thing only with a b, right? And it turns out to be 1 over x natural log of b. We're not going to use these very often. I just don't really like to use them. It's not a big deal. These are much more common, so we're just pretty much going to stick with this. I just wanted to make sure that you saw that. So if there is a base other than e, just know that it's a little bit different. You have that natural log of b, 2 or 3 or whatever in there. So just double check with your chart that it's in the right place. That's what I would say about that. So what we're going to do is now we have the chain rule. So I guess I'm not going to use this. I'm going to get rid of this. But I can then use this with the chain rule to do more derivatives. So I'm going to do a few here. And you'll see, by the way, it written this way. So let me write it that way. So if this is u, natural log of u, right, then I would have 1 over u, and then chain rule. So chain rule, if y equals natural log of u, dy dx is going to be 1 over u du dx. Okay, so the whole u gets in the bottom. So if I do dy dx here, it's 1 over everything in parentheses times the derivative of the thing in parentheses. Okay, so then my answer is going to be 8x over 4x squared minus 6. And you can do a little simplification, or you can leave it that way. Okay? in contrast, let's be careful. Here, of course, it's natural log of u. The inside function is the u. If I have something like natural log of x to the 5th, then my outside function is the power, right? So I'll get 5 ln x to the 4th, and then times the derivative of natural log of x. So I would have 5 ln x to the 4th all over x, right? Because this derivative is going to be 1 over x. So then it's just like using the chain rule with this new rule about the derivatives for natural log. Let's see what I got. I got a couple more sort of fairly simplistic ones. So natural log of cosine of x. This is kind of cute. So again, I'm going to do 1 over what's in the parentheses times the derivative of what's in the parentheses. So 1 over cosine of x times the derivative of cosine of x. Okay, so the derivative of cosine of x is negative sine, right? So I get negative sine of x over cosine of x, which actually is, right, negative tangent. But I could leave it that way. If you leave it that way, it's fine. Okay? Contrast with if I do it the other way. In other words, if my function is different, because these are two different functions, right? Here, it's the natural logs on the inside. So basically, I have this g circle f or f circle g. They're different, right? Do the same thing. But now my outside function is cosine, right? So I do minus sine of natural log of x times the derivative of the natural log of x, which is, of course, 1 over x. So I end up with minus sine of natural log of x over x. So pretty different, even though you're using the same functions, but they're in a different order, right? So you're getting this little bit different thing here. Now I wanted to show one more example of this, which we can do the same example two ways. So sometimes they'll give you something rough, right? I guess I had it this way, but it doesn't really matter, right? So this is going to be a little bit ugly because I've got a quotient and everything. So if I do dy dx, I'm going to do 1 over all of that times the derivative of all of that. I'll just write it. Okay. So, because I need space now, I need space. So what I'm going to have is, so this is just going to be the reciprocal, right? So I get that is going to be the reciprocal. And now I have quotient rule for the derivative. So the top times the derivative of the bottom, right? This is going to be 1/2 2x minus 9 to the negative 1/2 times the derivative of what's inside, so that's another 2, minus that 2x minus 9 times the derivative of the bottom, which is going to be 8x. Okay, so I could spend a lot of time kind of cleaning this up. Like, I could, right? This cancels with that. This is underneath. Break it up. Okay, that can, all right, I can't go too fast because I'll screw it up. So the first part, these two cancel. The first part, I've now got 4x squared plus 8. I've got 1 over this guy, and then 4x squared plus 8 with this guy in the bottom, and then this guy here, right? So that's this piece. And then, because remember all this was by this, but I canceled those out. And then for this guy, I'm going to get rid of that. This guy, oh, I forgot this already. See, I almost screwed it up completely. 2x minus 9 times 8x over this square root of 2x minus 9 times this 4x squared plus 8, right? So these guys cancel, these guys cancel, these guys get together. So what I actually ended up with when I broke this up was that. All right. Again, usually I'm like, just leave it. Unless you have to. Sometimes you might have to clean it up. So that was kind of ugly, right? And before I'm done, I'm going to show you something else you can do. Sometimes you can use properties of logs. So remember your properties of logs, right? Natural log of x times y is natural log of x plus natural log of y. Natural log of x divided by y is natural log of x minus natural log of y. And then if I have something to a power, x say to the c comes down in front. Okay? Yeah. All right. So you can use those in a situation like this. If you don't want to do that, you can simplify this thing first. I can rewrite this as natural log of, well, this would be 2x minus y to the 1/2 minus natural log of 4x squared plus 8, right? And then I could even pull that one down, so then I would have 1/2 natural log of 2x minus 9 minus natural log of 4x squared plus 8. Now these are much easier to take the derivative of because I don't have to do any quotient rule or anything. Right? What do I have? I have, okay, 1 over 2x minus 9 times the derivative of 2x minus 9 is 2. And then 1 over 4x squared plus 8 times the derivative of that, which is 8x. And lo and behold, it's actually the same thing. Yay! So sometimes you can make your life easier by doing stuff like that. If you forget, then you just have to make, do it the messier way.